Z. Okay.
Excuse me, sir.
Yes.
For the centroid to be in the middle, doesn't the shape has to be symmetric at both top and bottom?
If you look at the shape at the top and bottom, no, okay. Not necessarily the shape has
Oh,
to be
I
same.
see.
The
Okay.
area has to be the same.
Oh, it
Hello?
makes sense. Yeah.
Okay, the area has to be the same. Okay. So for this one, I'm not going to find it. Okay, you just going to take it from me because I want to teach you all about this example. So I'm just going to say the central is there. Okay. Hey, online, who started the Microsoft whiteboard? Oh my gosh. Now I have to get out from it. Hold on, there's some issue on online. Okay. Uh, I don't want to collaborate. Let me see. Can someone turn off the collaboration or whatsoever? How do you do that? Not now. And I'm going to hold on. Hold on. I'm going to share my screen again. Okay, can you all see my screen again? Those online, are you okay?
Yes, yes, right now
Okay.
it works.
Okay, it's okay. It's just by accident that happened. Okay. Right. So now we have I wrote the central is there. So we are also given that tau max is equal to Vy over Izz, okay, Qz divided by T, or just tau, okay, just tau, just tau. Oh, sorry. So we know. Let's look at this equation. Okay. For tau max to occur, yeah, I should zoom up. My apologies. For tau max to occur, we know that Vy is constant over what? Izz. Ideally, okay, there are two cases where tau max will occur. One is where you have Q max or Qz max, right? And the other one divided by T. This is situation number one. The other case is where tau max will occur when Vy over Izz is just Q, but you have T what? Minimum. Okay, so the Q and the T are always fighting against one another. Okay, are always battling against one another. Okay, now coming back to our question down here. Why I picked this question? Because this question is a combination of uh, box beam and wide flange analysis. Okay, it's a combination of box beam and what? Wide flange analysis. Okay, so before we go on, the first thing that we're going to do is we are going to construct our what? Shear flow. Okay, so I'm going to draw our shear flow now. So this is the web controls the flow. This is where our Vy is applied. So this is a terminal. So it does this. Okay. So we started from one terminal, then we ended up with two separate terminals. So construct your shear flow first, okay? And this structure is both a box beam and wide flange for this reason, okay? So I'm going to call all this Q, okay? So I'm going to copy again. I'm going to draw our centroid. If or when I take this box and I cover here, what does this look like? Box beam or wide flange? Box beam, isn't it? It's now a what? A box beam. Now, some of you say, Eugene, how can you happy cover one place and not cover the other place? Yes or no? I'll tell you why. I'm mafia. I do what I like. No, that's not a fact. Rule number 4. The first moment of area cannot cross the what? Centroid. Yes, that's why I can cover it. Okay, so if I cover the bottom, the top part, okay, the top part will be a what? It will be a box beam analysis. Okay, let me explain what's going on, then we proceed. So we have from the top, right, our terminal, you have Q doing this. So you have one Q here, the other Q there. Okay. Now, if I cover the top and expose the bottom, right, again, that is our centroid. I cover this now. I draw the shear flow. Q on one side, Q on the other side. You have one terminal here, you have one terminal here, you have one terminal here, you have one terminal here. Now, this is what? Box beam or wide flange. Where the left terminal and the right terminal, are they connected in any way? No. So for this case, when I cover the top, expose the bottom, this is known as a wide flange analysis. Okay. So you can see, right, by just covering the bottom or covering the top, your analysis what? Changes. And why we can cover it? Because rule number 4, the first moment of area cannot cross the centroid. Okay. Now, the 5 or 6 rules that I've created, you can look at any textbook. No rules. Okay. That's why other universities are so afraid to teach this topic. We are not. Okay. Because once you obey those rules are derived mathematically. Okay, not because I'm mafia and I set the rules. No. Okay, derived mathematically, and I've solved too many problems to see these rules happening. Okay, lucky you are taking this course now. 5 years ago, if you have taken this course, you will not understand it because I have no rules also. I also don't understand the topic really well. 5 years ago, I was 45. Okay, then I understand properly what's going on. You guys are much younger than me, know this stuff early, okay, and earn money out of it. Okay. Enough of me convincing you why this is good. Okay. Now let's look at the box beam analysis at the top. Yeah, let's look at the top. So like how I teach you, if it's box beam, this is equal to 2Q. Okay, and the thickness is equal to 0.2 inches. Okay. Now, what we want to find in this problem, right? We want to find the By over Izz ratio. Okay. Why we want to find this ratio is because this ratio is constant in any point of the structure. Right? Not in at any point of the structure. Right? Because what did I say? Rule number 1. V and I are what? Constant. Okay? So once we want to find the ratio, we no need to go and find what is our what? Izz. Right? Don't start the problem. Okay, I have to find Izz. No. Okay? So we are given that tau max. Okay, we are given that tau max is equal to 10 times 10 to the power 3 psi. Okay, so now we have to see, is it point A or point B going to be its tau max, or is it at the centroid? I don't know. Okay, so we have to check. So there's 3 points we have to check: point B, point A, and then we have to check at the centroid to see where is the what maximum. Okay, so here we go. We want to find the QZ at point B. So the width, okay. So the width. Let me see. Can I bring this to the back? Can I arrange? Send back. Okay. Oh shoot! Now send back. You cannot see anything. I move forward. Bring forward. No. I'm going to. Sorry, my bad. I'm going to send this to the back. Okay. I'm going to copy this image so you can see the dimension better. Come on. Pardon me. Okay. Wait. Give me a minute. My bad. Okay. Let me make this picture small. Then when I write, you know the dimension. Okay. So those of you online, I think can see better down here. You have to squint your eye. I apologize. Okay. So the width is what? 1.4. The depth is 0.2. Okay. So where I'm looking at is I'm looking at this area now. Okay. And then the y bar is 1.5 minus by 0.2 divided by 2. So this will be equal to 1.5 minus 0.2 divided by 2 times 0.2 times 1.4, 0.392 inches to power of 3. I'll do it again. 1.5 minus 0.2 divided by 2 times 0.2 times 1.4, 0.392. Okay. So now we want to find the shear stress at point B is equal to Vy over Izz, right? The y is 0.39, the q bar, the first moment is 0.392. We have to divide by 2 down here because it is what? 2q. And then the thickness is equal to 0.2. So this is equal to 0.392 divided by 2 divided by 0.392 divided by 2 divided by 0.2. 0.98, okay, Vy over Izz.
Sorry, what about the web portion?
At point B, you don't consider the web.